All right, let's talk about DNSSEC. You can think of it as the locking key for the Internet's phone book. It's this really crucial layer of security that makes sure the whole system we rely on every day stays trustworthy.
I mean, think about it. Every single time you type a web address into your browser, you're basically just trusting that you'll end up in the right place. But what if that trust is broken? How do you really know? Well, that's the big question we're going to tackle. So at the very heart of all this is something called DNS, the domain name system. And honestly, the best way to think about it is as the Internet's phone book. It's a simple idea. You look up a name you can remember, like example.com, and it gives your computer the IP address, the actual number it needs to connect. So here's our game plan. We'll start with why that phone book isn't as secure as you might think. Then, we'll see how DNSSEC forges what's called a chain of trust to fix that. After that, we'll look at a dashboard that lets you see all this, decode what the report is telling you, and finally, turn all that info into action.
Okay, so let's get right into the problem. That phone book we were talking about, as it was originally designed, well, it's just fundamentally insecure.
And this right here is the hidden danger. With regular, standard DNS, there's absolutely no built-in way to check if the IP address you get back is the real one. A bad actor could just jump in the middle, intercept your request, and send you off to a fake website. And you'd never even know. You'd think you're on your bank's website, typing in your password, but it's actually going straight to a thief. And this table really gets to the heart of it. With standard DNS, trust is just assumed. You just kind of hope you're getting the right answer. But with DNSSEC, that trust is proven. Instead of just hoping, you get answers that are cryptographically signed, which protects you from being secretly redirected. It's the difference between taking a stranger's word for it and getting a verified, sealed document.
So how does it actually prove anything? Well, it does it by building this amazing, unbreakable, and verifiable chain of trust.
It all works in a hierarchy. It starts at the very top, with the Internet's root zone. That's the ultimate source of truth. The root then cryptographically signs for the next level down, which are the top-level domains, like .com. And then, in turn, the .com registry signs for your specific domain, like example.com. Each link in the chain vouches for the one below it.
So what actually holds this chain together? It's all about a few special DNS records. The DS record is like a fingerprint that you leave with your parent. So with the .com registry, that fingerprint has to perfectly match your DNS key, which is the public key that you publish for your own domain. If they match, the trust flows down. And the last piece is the RSI sig. That's the actual digital signature that proves your data is the real deal and it hasn't expired.
Now, I know that sounds pretty technical, and it is. But the good news is we have tools that can just show us how this whole chain is doing. So let's switch gears and look at a practical security dashboard.
This is kind of the high-level view. Good tools give you these executive scores that just boil everything down to simple colors. Green, obviously, is good. Everything's working. Orange is a warning, like, hey, you might be using some outdated crypto. But red means something is actually broken right now and you need to fix it fast.
So let's dig in a little deeper behind those colors. We're going to decode the health report by looking at some of the most critical security metrics. First up, and I mean, this is the big one, is trust chain integrity. Honestly, if this part fails, nothing else really matters.
What this check does is simple, but it's absolutely vital. It just confirms that the DS fingerprint that's stored up at the parent level matches the public DNS key that's in your zone. If they don't match, the chain is broken, period. Your domain will fail validation, and for some people, your site might just disappear from the internet. It is a critical failure.
Okay, next up, the crypto profile. See, it's not just enough to have signatures. The strength of the cryptography behind them is just as important.
So you'll see things like this, showing which algorithms are in use. Modern ones like SHA-256 or ECDSA, those are great, very strong. But if you see something like SHA-1, that is a major red flag. It's an outdated algorithm that's basically considered broken now. If you see that, you need to start planning your migration to something stronger. Another really important factor is time. These cryptographic signatures, they don't last forever, and that's by design. They have an expiration date.
You can think of this as a countdown clock. Every single DNSSEC record has a signature, that RSIG we mentioned, and it has an expiry date. If that signature expires before you get a new one, your domain's validation will completely break. So you've got to make sure your records are re-signed before this timer ever hits 0.
Okay, so we've looked at all the things that could potentially go wrong.
Now let's talk about the most important part, turning all these insights into a clear, actionable plan to get your domain secure.
A really good report won't just throw data at you. It'll give you a prioritized to-do list. Critical issues like that key mismatch we talked about, you fix that immediately. High-priority things like signatures that are about to expire, you address those very soon. And then medium things like migrating away from SHA-1, well, you can plan for those. It turns a complex report into a straightforward checklist.
And you know, this quote really says it all. DNSSEC isn't just some feature you turn on. It's a fundamental shift. It takes the old, hope-based security of DNS and replaces it with cold, hard, mathematical proof. You're no longer just hoping the answer is right, you're proving it. Which brings us all the way back to our first question. But this time, it's for you. After seeing all this, think about your own domains. Is their trust something that's proven with verifiable cryptography, or is it still just being assumed?